All right, good morning. So this video is to talk about and get data for our 7.3 double displacement and precipitates lab. So if you're absent for this lab, basically what we're going to do is we're going to have six actually, double displacement reactions that form precipitates, okay? And so what we really want to make sure we understand is when we're looking at this, we talked about our two type of displacement or replacement reactions, okay? And so we can see here, let's see if I can do this. Oh, okay, on our single displacement reaction, um, we have element A, that displaces or replaces element B, right? So we can say, okay, zinc simply kicks out or replaces hydrogen and now bonds with sulfur. So our products in this, we end up with zinc sulfide and then hydrogen, right? So hydrogen was displaced, right? So we had one element replacing a similar element, right? So that's our single displacement. So now double displacement, we can think along the same lines. So instead of one element being replaced, we could technically say there's two. I like to really think of it as just our metals trading places, okay? So here we have NaCl, we have our metal and our nonmetal, and then we have silver nitrate. So again, a metal, and then our polyatomic ion, which is a nonmetal. Okay, and so what we see here is A just trades places with C. Okay, so when we recombine them now, instead of AB, we get AD, right? They just traded places, and CB. Now, why did I put C first? Because we always remember within an ionic compound, we're going to list our metal first. Okay, so an example of that we're going to see in the lab is we take NaCl solution and a silver nitrate solution, and when we mix them together, we get this double displacement reaction where the silver and the sodium trade places. So we end up with NaNO3, or sodium nitrate, and silver chloride. Okay. Now, why is this a precipitate reaction? This is kind of the cool part. We'll see if we can show this here. I'll try and write it nice and big so you can see also. So one thing that we talked about in this lab was the state of matter, or what state these compounds are in. So NaCl, when we put it in water, it dissolves, and so we call that. You might see a little AQ down here. Drew it nice and big so you can see. What that means is that sodium dissolves in water and we can't see it. So we've done this with salt or sugar. You put it in water, stir it around. You don't see it, right? Because it dissolves. Same thing happens with our silver nitrate. It's aqueous. Okay? But there are certain things that don't dissolve in water. We call those insoluble, right? So what happens with our product then is we end up getting something that doesn't dissolve in water. And how we know that is we see this S, right? We get this solid. Okay, so what that means is it forms a solid. And when we have a solid, then it drops out of solution, right? It falls out of the solution. So that's why when we look at our precipitate title, that's really what it's talking about. We have two dissolved compounds, and then when we mix them, they form a new compound that then drops out of the solution, just like rain drops out of the sky or snow drops out of the sky. We call that precipitation. This is our precipitate. So it's falling out of solution and is no longer dissolved because it's insoluble. Okay. So that's kind of what we're looking at in this lab. That's kind of cool. They're kind of some neat reactions. So let's go over to the lab station here. I want to see if I can before we do that, let's talk about what we're looking for. So in your notebooks, just like normal, we want our title, lab number, make sure you put your name on it. And then as we go through these, we do want to get our purpose, right? So the purpose of this is we want to be able to create and describe a precipitate, right? So what is that precipitate? And then write a balanced chemical equation for a double displacement. That's going to be kind of the key for our analysis section. We're going to actually be able to predict what our products are going to be. Okay, so make sure we get those things added. Then when we look at our data table here, what we're looking for is we're going to have our 6 reactions. And I just basically want you to note, what was the starting color? Like, what did we see? Was it transparent? Was it clear? Was it orange? Was it blue? And then after we do the reaction, what happens to that color? Okay. Now, very next thing, for the analysis, it says, okay, write the reactants of each precipitate reaction. use the previous slide to write the chemical formulas for each compound. Okay, so what that means is this is giving us the reactants for each chemical reaction that we're going to do. Okay, so remember the reactants are the things that go into the reaction. So we know we're going to mix NaCl with AgNO3. So how you'd write that is just like we see on the board here. So we take NaCl plus AgNO3. Okay, so we're going to have to do that for all 6 of those reactions. So go ahead and pause the video. And so again, so we can see I got NaCl plus AgNO3, and then have your arrow. We'll talk about how we get the products later. Okay, same thing, BaCl2 plus Na2SO4. So we're just going to list those out. So take a second, pause the video, make sure you have those ready to go for your analysis section. That way, when we're done, we could talk about how do we figure out what our products are going to be. Okay, now let's see if I can. Uh-oh, I just want full web. Uh-oh, can I make it bigger? All right, there we go. Okay, so let's see if we can do this here. So with our first reaction, what we want to have is we want to have sodium chloride or NaCl, and we're gonna mix that with silver nitrate. Okay, so here's our NaCl, so you can see. Okay, it's just a nice transparent liquid. Our AgNO3, our silver nitrate, also clear and transparent. Okay, but when we add our drops, whoa, look at that. Wow. Okay, so what actually starts to happen here is you can see we're getting that cloudy liquid is actually a solid that is dropping out of solution. Okay, it's insoluble. Okay, so we can see now, wow, that changed to a nice cloudy liquid, and it'll settle out to the bottom. Okay, so that's the first one. Okay, so go ahead and pause the video if you need. So each time I do one of these reactions, just go ahead and pause the video if you need to, and then record your observations. Okay, so now next one. Next one we had barium chloride, or BaCl2, right? Again, we got a nice clear liquid, and we're going to mix that one with sodium sulfate. Again, another nice transparent liquid. Okay, when we do that, again, look at that. Wow. Okay. And so we can see there then that, again, we're having something that is forming in that solution that is insoluble, meaning it doesn't dissolve. And so that's why we can see it now. It's forming a solid. Okay. Go and record your observations on that one. Now, next we have potassium chromate, or our KCrO4. Okay. So this one you can see it's a kind of an orange color, right? But if you really look, you don't really see any solids in there. Okay, so there's not any solid pieces. It's still pretty transparent. It's just got an orange tint to it. And again, we're going to add silver nitrate to that solution. Okay, so let's see what happens here. Whoa, look at that. Holy moly. Right? It goes like a real tomato juice color. This one's kind of cool because as it separates and as it drops out of solution, we get a real rusty brown color deposit on the bottom if you give it time. So maybe at the very end, we'll look at that one. Okay. So very, very distinct color change there. Okay. Now, next one. This is one of my favorites. So, in our test tube, we have sodium hydroxide, or NaOH. So again, got a nice clear, transparent liquid. Our test tube's a little dirty because kids are crusty butts. And then we're going to add some copper sulfate. So you can see this one definitely still it's transparent, definitely a blue tinge to it. Okay. So when we add, let's see. Oh, look at that. Right? And so you can kind of see that clumpy stuff drop out and settle at the bottom, right? Very interesting. So we have that very solid precipitate falling out of solution. We can already see that it's collecting at the bottom, right? So we can see we got a clear liquid up top, and now we got the solid at the bottom. Okay, that one's pretty cool. Okay. All right, now this one. Okay, so we have potassium iodine. So this should be station 5. Okay, so again, nice clear liquid. And then we got some lead nitrate. Okay, another clear. Whoop, there, got another clear liquid. So this one, let's see here. Whoa. Okay. Wow. Right. So that one, I don't know if you guys can see, but if you look really close at it, we form this kind of like almost chalky looking yellow solid, right? So again, another precipitate form. All right, last one. We have sodium hydroxide, NaOH, and we're going to be mixing that with our silver nitrate. Okay. Last one. Ooh, gross. Right? Now get that nice tan solid precipitate in there. Okay. So again, the key with this lab, guys, is understanding, okay, what's happening here? We have two compounds that are soluble, meaning they can be dissolved in water. And when we combine that, we have a chemical reaction, and one of our products becomes insoluble. It's a solid, and then that's where we end up with something that we can see, right? Something that drops out of solution. So we think rain drops out of the sky, precipitates fall out of solution. Okay. So now let's look at our analysis portion. Okay. All we need to do for this gets a little bit trickier. Actually, I'm going to make another video on it because we have to go back to what we talked about with our writing chemical formulas and understanding, okay, what is the oxidation number of each of the components in our compound, and then crisscrossing those oxidation numbers. So in this lab, we got to do kind of a lot of the things that we talked about. So we got to be able to say, okay, we got to find oxidation numbers, uncrisscross to start. Then carry those oxidation numbers over into our products, re-crisscross. That way we can get the correct subscripts. Once we get the correct subscripts, then we can go forward and balance our equation to make sure we have the right ratio. So look for my second video on this. Bye.